This is the third video that I'm doing on linear systems using matrix techniques to solve them. Um, if you've looked at the other two videos, you might, let me just expand this a little bit here and get rid of the stuff here. So, whoopsie daisy, there we go. Check on the focus, just give me a second here. Okay, let's do this one down here. This one sometimes works better. Perfect. Now, sorry for the delay getting started. The second video ended with this matrix. And where we were then is we had determined the value of z, and we had a 1 here and zeros. And we'd gone through the process that's referred to as Gaussian elimination. And I stopped there and I said, hey, why don't you finish it off if you would like? As a matter of fact, I think I did one other step down here, and I found what z was -4, found that y was -1, and I said, why don't you finish it off and see if you can determine what the x value is. So I decided I would go ahead and do that for you in this video, and I decided the easiest way to do that is to just use it as a way to demonstrate the technique that's referred to as the Gauss-Jordan elimination method. Now, you do have that described for you in the slides, and you'll notice that the pattern that the PowerPoint slides go through some steps, but you'll notice the pattern that you're after is you're trying to get a matrix that has ones down the diagonal and zeros everywhere else. Now, what we did achieve in the Gaussian elimination is we did get, eventually we got zeros here, here, and here. We just never did, we didn't finish it off. So you can look at the slides and you'll see that if you go all the way through using the Gauss-Jordan elimination technique, you're going to wind up with 1x is equal to a value, 1y is equal to a value, 1z is equal to a value. And so this is the completely solved matrix. Now let's go back and just look quickly at the matrix row operations that I used to get to this point. So you'll notice this is the matrix that I had in the last video, and I said, all right, why don't we just do this? Why don't we see if there's a way using 0, 0, 1 in this row, if there's a way to get a 0 here. And that's pretty easy. You multiply this bottom row by 30/37 and you add it here. And so that's going to cancel out the negative 30/37, and I'm going to wind up with 0, 1, 0. Now this arithmetic is more algebra, where you had to multiply 30/37 times this value. And you had to go through a little bit of fraction work, to get this accomplished. You multiply 30/37 times -4, which is going to be what? -120/37. And then we converted that to 185ths. Why? Because this has got a denominator of 185. And I combine those two and immediately get -1. And so I find now that what? Z is -4, Y is -1. And I'm getting real close now. All I've got to do now is just do what? I already had a 1 here, so I need a 0 and a 0 here. And so that'll be easy. I'm going to multiply 1 down here, 1 down through here, and I'm sorry, I went this route next. I'll multiply -4/5 here through here and add it up here. So -4/5 plus 4/5 is 0, and the -1 didn't change. Anything times 0 is 0. Then I had a -4/5 combined with what? A -4/5, and then came back down through and multiplied through by 1 down here. Okay, so let me say that again. When I multiplied the -4/5 here and added to here, I had a -4/5 times a -1, which is +4/5. +4/5 and -4/5 is 0. And then I multiplied the bottom row by +1, which is going, and added it to the top row. And this doesn't change the 1. This doesn't change this 0. 1 times 1 is 1, and a -1 is 0. Now here's the punchline of that. +1 times -4 is -4, and you add that and you get -4. So suddenly now I have this matrix. 1x -4, 1y -1, 1z -4. And those are the answers that we had before when we went through the linear systems, the original problem that we had. We had an x that was -4, we had a y that was -1, and we had a z that was -4. So this was, once I got through the Gaussian elimination, this was just a few more steps of matrix operation to get to the Gauss-Jordan form of this matrix. Now, I'm going to highlight this just a little and a little curve. So this is a 1, this is a 0, this is a 0, this is a 0, this is a 0. There's a value here of -4. This is a 1, this is a 0. There's a value here of let's say -4. There's a value here of 1, -4, 1, -1, a 0 here, a 1 here, and a -4 here. Now, the key thing I want you to pay attention to is I want you to pay attention to the format of this matrix, where we have these ones down the diagonal. Now, we're going to find that there's something special about the matrix when we get it in this form, other than just being, oh, I can just read off what the answers are. Now, x is -4, y is -1, z is -4. So I'm going to stop this video, and I'm going to pick up in the next video with a conversation about this matrix. And now you can appreciate the amount of effort that it took to get. You can appreciate the amount of effort that it took, I think, to get to this point. And I want to come back to that a little bit in the next video.